Well, thank you everyone for joining us this evening. You were brought into this session with your microphone and video off. If you have questions, please put them in the chat. Ethan will be collecting them and will address them to Dr. Christensen one time at about the middle of the presentation and one time at the end. This program is being recorded and it will be made available on the Detroit Public Library YouTube channel and through Wayne State University's website. I will give you the YouTube link later. I am Jennifer Dye, a librarian at Detroit Public Library. We've had astronomy programs for several years, and we used to have them in person. And starting in early 2021, we started presenting them online. We've been fortunate to work with Megan McCullen, director of the Wayne State University Planetarium. In addition to supporting the Zoom programs, she has provided a link into the community of Wayne State University faculty and alumni, including tonight's presenter. She isn't available to join us tonight, but Ethan Partington has volunteered to collect the questions and ask them during and after the presentation. Ethan, would you like to say something about the program?
Yeah, the Wayne State Planetarium program?
Yes.
Absolutely. So we offer free shows to the public every Friday at 6 o'clock and 7:30. These are a 30-minute live feature film followed by a live star talk given by one of our astronomy presenters. These are students who are studying astronomy and bringing their research into the dome for the public. On the first Friday of every month, these are reserved for Wayne State alumni, faculty, staff, retirees, and students, but the rest of the Fridays in the month are available to everyone. So if you're not part of Wayne State, don't worry. All you have to do is attend as a walk-in guest. We no longer use Eventbrite, but you can just show up to our planetarium located in the basement of Old Main, and we will let you in for the show.
The shows are very worth seeing. I've only been to a few of them, but they have been very worth seeing. Our presenter tonight is Dr. Mark Christensen. He was born and raised in the Detroit area. He studied mathematics and physics at Wayne State and Purdue universities. After he completed his doctorate, he served on the faculty at Georgia Institute of Technology and Northrop Grumman, and as a consultant in the operational test and evaluation of airborne radar and electro-optical systems. He has previously presented for us on the science and technology of the James Webb Space Telescope before the launch, and he led us on a world tour chasing total solar eclipses. Both of those programs are available on our astronomy YouTube channel. Dr. Christensen, would you care to start?
Okay, let me see if I can share. And okay, hopefully you're all seeing the guest screen and not the presenter screen. So anyway, yeah, this is a talk about the upcoming April 8th solar eclipse and how you would view it safely. We'll just dive right into it. We'll talk about eclipses we'll very briefly talk about eclipses in general, but the emphasis is going to be on this eclipse, where you can observe it from, focusing mostly, of course, on the Detroit area and Ohio, which is immediately to the south, and then how you would observe it safely, focusing on the partial phases, because it's not total in Detroit itself. But even if you're in the area of totality, most of the hours of the eclipse will in fact be partial, and the sun will be quite bright. And so we're going to focus on that primarily, on how to safely observe the eclipse before totality and after totality. So this is basically our agenda. We'll talk about eclipses, why should you worry about it, how to view the sun safely, and then a summary and questions. Okay, what causes eclipses? Well, it occurs when the moon passes in front of the sun. It doesn't happen very often because the orbit of the moon is tipped 5 degrees relative to the plane of our solar system. If it wasn't tipped 5 degrees, we would have a total eclipse every new moon. But it's only when it happens that the moon is new and it happens to be, and the two planes happen to be crossing, that you'll see this. So there's barely 1 chance in 10 that on any new moon that you would see even a partial eclipse. And of course, the chance that it's total anywhere is even lower, and it's even less than in the USA. And so if you want motivation to go out and see this eclipse, whether you see it partially or whether you see totality, the next one that's going to occur in the USA is in 2044. So unless you plan on going to Santiago, unless you plan on going to Spain in 2026, for example, this is your big chance. Okay, what causes eclipses? As I said, it's because this is viewed from the top. When you look at the solar system from the top, it looks as though you'd have an eclipse every month. But if you, in fact, take into account the fact that the two orbital planes are tipped, you'll see that most of the time the shadow of the moon misses the Earth. But if the two planes do coincide, here's a view from the top again, then you'll get a total eclipse of the sun. The moon also has to be at the right distance. Just this last year, we had a so-called ring of fire or annular eclipse when the moon was at its most distant from the Earth, and so it didn't totally cover the sun. And if you wait a few 100 million years, we won't have total eclipses anymore anyways, because the moon, because of tidal effects, is gradually moving away from the sun. This particular eclipse that we'll be talking about occurs on April 8th of this year. And in the Detroit metro area, the partial phases begin at about 2 p.m. And of course, if you move around in the country, it'll be slightly different, irrespective of time zones. The total duration of the eclipse is 2.5 hours. In Detroit itself, the peak eclipse will be 99.4%, which means that 99.4% of the disk of the sun will be covered. If you want to see it total, and I would urge you to do that if you possibly can, you need to head down to Ohio or Indiana or Southern Illinois or Missouri or Arkansas or Texas, or go to Mazatlan. I'm told at least one cruise line has a cruise that's going to be off the coast of Mazatlan, which actually has the best chance of having clear weather, by the way. In Detroit itself, as I said, the eclipse begins at just about 2 o'clock. The peak, which is not total, it's 99 point, well, here I said 0.1, and now the other one was 0.4. Oh, well, it'll vary that much over the metro area. The peak will occur at around 3:14 p.m., but it won't be safe to look at with the naked eye because of the fact that part of the sun, which is extremely bright as we will see, part of the disk of the sun will still be visible in Detroit. And then the partial phases completely end. The moon moves off at 4:27. So here's a simulation showing what it's going to look like. The little circle down here is the disk of the moon, and of course the sun is this big bright disk. So at about 2 o'clock, the moon first comes in contact and starts to cover part of the sun. But as you'll see in downtown Detroit or anywhere in the metro area, you're not going to totally cover it. The two disks won't totally coincide. So a small fraction of the sun will still be visible, and it will still be quite bright. In fact, it'll look something like this. That tiny little section of the sun will be so bright that it'll create what's called this diamond ring effect, which is seen at the beginning and end of totality. In Detroit, it'll look like this at the best. If you go to Cleveland, which actually at the Great Lakes Science Center, there's an event planned, which you can register for. It begins again almost exactly at 2 o'clock. Totality's at almost the same time, but totality lasts for 3 minutes and 50 seconds. Now, if you go all the way down to Texas, it's going to be 4 minutes and 30 seconds roughly. So from a standpoint of the duration of totality, you're just as well off in Cleveland or Lima, Ohio, or south of Indianapolis or south of St. Louis as you are in Texas. The difference is going to be the statistics for the weather. But in Cleveland, the sun, because the geometry is slightly different, it looks the same as our simulation for Detroit, but you'll see that the moon completely covers the sun for those 3 minutes and 30 seconds or whatever. And then it moves off. The flashes are a figment of the computer. So it'll be total in downtown Cleveland or in Lima, Ohio, or other places. Here's a video also showing giving you an idea what it would be like. This is during totality down in Missouri in 2017. We had some high haze, but this is totality. And then as totality ends and the sun moves and the moon moves off, you'll see how rapidly it gets bright, even though a fraction of a percent of the sun is visible. And that's why you've got to be careful when viewing a solar eclipse. And by the way, you don't need to be paranoid, but you just need to be careful. But it'll be that bright probably most of the time in Detroit. Now, you see this little segment? That's viewed through a special filter that only lets in less than 1/10,000th of the light. You saw how bright it was before. That's what it would look like through a special filter, which we'll talk about later. Okay, here's the path of the whole eclipse, starting in Mazatlan and Durango, going up through Texas, through Arkansas, southern tip of Missouri, southern bit of Illinois. The color codes represent the percentage of cloud cover. When you get up towards Ohio, statistically on that date, you're looking at 70, 80% chance of clouds. When you go down to Texas, it's maybe 20, 30%, but it can be as high as 50%. And of course, that's statistics. It's climate. It's not weather. So on the day it happens, it could be that it's totally cloudy in Texas and Mexico and totally clear in Indiana and Ohio. You just don't know until we get there. So set your expectations appropriately. Here's the path that's of most interest to people, I would think, in the Midwest, whether you're in Chicago like I am, or whether you're in Detroit. That's the path of totality. The center line is the fine line down the middle of the shaded area. You don't have to be exactly on that line. If you were in Sandusky, for example, you would see almost as much totality as you would see in Cleveland. So you don't have to be religiously right on that center line, but you need to be pretty close to it. And the closer, the better. But if you have a choice between having a crisis and being right on the center line, avoid the crisis. Move off the center line. And as I said, there are various websites that give you events, and I'll give one in particular that's useful from the Planetary Society that will give you where events are occurring for the eclipse throughout the country. Now, for anyone who's never seen it, this down here is at the bottom of this slide, you see a representation of the partial phases before, during totality, when there's no filter, and then afterwards when you use a filter. The point I'd like to make is those filters that are shown here cut out 99.99% or more of the light. And the reason for that is that the sun is incredibly bright. Now, if you think about it, normally you wouldn't even think of looking directly at the sun. Eclipse publicity makes it more likely that people will. And the point is with proper precautions, it's perfectly safe. But you've got to take the precautions and plan in advance. And during totality, the total light coming off the solar corona, which is the milky area around the sun's disk in the center there, during the totality, the total light coming out is about the same as the full moon. You can actually see stars during totality. But as soon as any part of the sun's disk appears, it's so much more incredibly bright that it'll wipe out everything else in the sky, and you don't want to be staring at it. Okay? So looking at the sun, other than during totality, without proper equipment, is very dangerous to your eye. By the way, there are never very many people who actually suffer eye damage because people are generally careful and commonsensical, but it doesn't hurt to be careful. So just how bright is the sun? Well, let's compare it to something we're all familiar with, a 100-watt incandescent light bulb, which I think would be about a 23-watt LED light bulb, if I got the numbers right. It puts out what's known as 1600 lumens, which is a measure of brightness of the bulb. The sun in our sky is 127,000 lumens, which is why you don't see people staring at the sun unless they're on drugs. So if you do just a division, you'll see that the sun is 80 times brighter than a 1,000-watt light bulb. And so I asked the question, if you had any common sense, would you stare at an 8,000-watt light bulb that was mere inches or feet away? You wouldn't. So don't do it during the partial phases either, unless you have filters or some other mechanism to cut that intensity down. Another way to look at it is typical room lighting is between 1,000 and 3,000 lumens. And again, that's compared to the sun's 127,000 lumens. So the sun is 42 to 127 times brighter than normal room lighting. So again, you wouldn't stare at that. Don't do it now, and don't do it during the partial phases of an eclipse. And of course, if you use a telescope and binoculars, it becomes even more dangerous because your eye's pupil is only about 2 millimeters in diameter in bright light. Well, a telescope's got an aperture of 2 inches, which is, or more, which is like 50 millimeters. So that collects a lot more light. So for example, suppose somebody wanted to use 7x50 binoculars. What would happen? Well, the 50 millimeter lens will gather 625 times more light than your eye would do when it's adapted. Now, the exit disc or the beam of light coming out of a 7x50 binoculars is 7 millimeters in diameter. That's done because your dark adapted eye dilates to 7 millimeters, but that's not going to be the case. But so the intensity coming out will be slightly smaller, but it will still be 1,000,000 lumens. So if you were to take unfiltered binoculars and look at the disk of the sun, not the corona, which is what you see during totality, but the disk of the sun or any part of the sun, you would be looking at upwards of 1,000,000 lumens. Now, again, nobody would stare at the sun with their naked eye without a filter, and you certainly wouldn't do it for something that was 7 times or more brighter. So to illustrate this, the human eye, of course, you probably know, has a lens. It's got a pupil, which expands or contracts depending on how much light you have, your ambient lighting, and then the lens projects the image back on the retina. Now, the daylight pupil is typically the order of 2 millimeters, which means it's 3 square millimeters area. So it's a tiny little area. But your lens of your eye focuses the disk of the sun onto a 0.2 millimeters image, which is only 3/100ths of a square millimeter. So in other words, all the light that's coming into this 2 millimeter pupil is going to be focused onto a 0.2 millimeter image in your eyeball. Now, if normally you get sunburn in half an hour or something on your skin. Well, your retina is more sensitive than your skin is, and it's going to be getting 100 times more intensity than your skin would. So that's why you don't look at the sun without filters. To show what happens if you have something like a 50 millimeter lens, which is what you'd see on a pair of common binoculars, typically you would get down to 625 times more intense. You don't want to put your eyeball there, and you don't want to put a camera there. Okay? So the sun is bright enough as it is, but when you put a lens in front of it to collect light, it's going to make it even brighter. The intensity will be greatly increased. In fact, you could set fire to paper if you put it at that focus. So there's 2 safe solutions. One is you drastically reduce the amount of light coming in the first place, whether it's into the eyeball, in which case you use what are known as eclipse glasses, which have very dense filters on them. Or if you're looking through a binoculars or a telescope, you put filters in front of the objective, in front of the first lens. Or, so that's one approach. The second approach is indirect viewing. You use a pinhole camera, or you project the image onto a screen that you look at. And the image will be much bigger, and so the light intensity will be lower, and you can filter it still. And again, you must do one of those 2 things, either filtering at the front or projecting onto a screen of some kind at any point during an eclipse outside of the total phase. And again, in Detroit or here in Chicago, it's not going to be total. So it basically means you need filtration all the time. And as I said, if you're in the right place to see totality, you don't need the filter for those brief 4 minutes. But for the other 2+ hours of the eclipse, the partial phases, you need the filters. So you must use one of those two methods if you're going to be in Detroit or elsewhere. And during the partial phases, anywhere you need to use filters or projection. So let's look at the filter option. There's 3 rules you need to have for this. First, the filter needs to be in the front of the system. Why? Because it keeps the radiation, the light intensity, from getting into the system in the first place. It's the safest way to do it and the best way. Rule number 2, that filter needs to reflect at least 99.99% or more of the visible radiation. And it needs to reflect all of the IR and the UV. UV radiation, you know, people talk about sunblock. It's the UV radiation that causes the most intense sunburn. And UV is invisible to the human eye from a sensing standpoint, but it sure can burn your retina. And the same thing for infrared. Infrared is heat radiation, and if it's not filtered properly, it can burn your retina as well. So why would you put it in front? Well, if you didn't put it in front and instead tried to put a filter between the eyepiece of a telescope and your eyeball, that would concentrate 625 times or more, 50 to 625 times more light. Heat intensity would be at this filter, which means if it's a film filter, like these are film filters, we'll talk more about that later. If it was a film filter, it's going to catch fire, and that heat's going to go right into your eyeball. This radiation is going to go right into your eyeball. And if it was on a glass filter, it could crack because it would get hot. So this is the wrong place to put the filter. So where you want to do it is put the filter at the safest place. Because if you put it here, it could fail. So you don't want to do this. Where you want to put it is in the front, because that keeps most of the radiation out of the system. It protects the telescope, and more importantly, it's a fail-safe for your eyes. So let's look at some numbers here. For binoculars or telescopes, you want to put the filter in front. Now, the sun radiation, as we said, is 127 lumens. These filters typically knock off all but 1/100 of 1%, which means that after the filter, it's only 12.7 lumens. Now, the telescope makes it brighter because it concentrates the light. All the light that's falling on this area falls on this image of the sun here. Now it's 8,000 lumens. Now that's the equivalent of an extremely bright room, which you wouldn't want to look at for a long time. But the eyepiece magnifies the image and makes it larger in your eye, so it is reduced down to something of the order of a few hundred or at most 1,000 lumens, which is well within normal vision. So if you're using, the bottom line here is if you're using binoculars or a telescope to view the eclipse during the partial phases, which again is all you're going to see in Detroit or Chicago, then you want to have this filter in front of your telescope or in front of your eyes if you don't have a telescope. So Ethan, are there any questions so far that you want me to address?
There are no questions in the chat yet, but if people have questions and just haven't written them in the chat, we could absolutely take a moment for you to pose those.
Okay.
And if you do have them as they come up, please feel free to let us know in the chat.
Can people see me clearly in their screens, at the side of their screen?
I can see you at least.
Okay, because I'm going to hold at various points. I'm going to hold some props up. For example, these are eclipse glasses, which are available from a lot of different sources. They are perfectly fine for viewing the partial phases of the eclipse, totally safe. But you don't want to put these on and look through an unfiltered telescope, because that material will burn, because the telescope will serve as a magnifier and will make the radiation much more intense. If you're wearing these, you're fine all by themselves. If you're looking through a telescope, you want to have a filter in front of the telescope. And I'll show some examples of those. And if we don't have any questions, I'll just keep going.
That sounds good. No questions yet.
Okay, either they're falling asleep or I've done a great job. Okay, there's two kinds of filters. There's metal on glass, and then there are films that reflect or absorb the radiation. And I showed you earlier some Eclipse glasses. There's also filters that are made specially to put on binoculars. Excuse me. They slip over the binoculars. Of course, if you're using filters on a telescope or on binoculars, you want to make sure that they are secured and can't fall off. Okay. And as I'll say at the summary, you also want to make sure that individuals who need supervision are supervised, whether they're young or old, because you don't want people, deciding, oh, I want to get a better look and take the filter off when your back's turned. These are other examples. This shows how they slip on the binoculars. And then this is one that actually is a universal filter designed to fit on a lot of different telescopes. And again, notice how they seem to reflect most of the light. And that's because that's the intent. Some of the filters actually, like this one here, which I use on a camera, this one looks black because it absorbs some of the light and reflects a lot of it. To give you an idea as to how this works, here's a flashlight, which it turns out, if you look right at it, is just about as, it's not quite as bright as the sun, but it's pretty bright. If I put this filter over it, I don't know if you can see it or not. Let me turn this desk light off. We can do a little show and tell later too. Well, now you're not able to see much, but watch what happens when I take the filter off. See how bright that is? So the filter drastically reduces it. And that's the whole point. Here's a couple other examples. This is one that was actually, they make particularly to put over your cell phone to protect it. This is an example of a glass filter. I've got one of those also here because that's what I happen to use on my telescope. And I've been using it for many, many years. See how it looks like a mirror? That's because it reflects 99.99% of the light or more. It just lets a little bit through. And again, if I hold this very bright flashlight up to it, you really can't see anything to it. All you see is the reflection. But boy, if I didn't have it there, you see how bright that is. And the sun's even brighter than my little flashlight. Now, these filters are not terribly expensive. They're in the range of $100 or even less. Some of them are in the range of $25. And you can get them from a variety of sources. Now, I'll repeat this again. Solar eclipse glasses are very, very handy, and they're very economical. This 4-pack, I think, with a pamphlet is like $25 on Amazon. And it comes from Celestron, who are one of the premier telescope makers. This is not for use with telescopes or binoculars. It is only for use on your eyes, period. Nothing else. Because if you use it with a telescope binoculars, the concentrated beam of light with unfiltered binoculars or telescope will melt these lenses. Because you're going to have the light that was jammed coming through a 2 or 3 or 4-inch telescope is going to be barreling into a couple of millimeters on the filter, and it'll melt the filter. So you do not use these with telescopes, but they work great on the eyeball alone. And that's what they're made for. Sources for these, you can get them from various photo dealers like B&H Photo Video, Adorama. Amazon, of course, has many, many suppliers with them. And they have stock. I keep checking periodically. eBay, there are suppliers for them as well. Various astro retailers like High Point Scientific and Astronomics, they carry them, but many of theirs are out of stock because these are smaller retailers. They don't have the purchasing power or the storage space of an Amazon. So you're not going to, they may run out. So, but you can get perfectly good filters of these types, whether it's for your camera, for your eyeball, for a pair of binoculars. You can get perfectly good filters from Amazon, Adorama, BH Photo Video, and other photographic dealers.
Dr. Christensen.
Yes.
I wanted to mention that in 2017, apparently they're, well, the library bought some from Amazon and then discovered that while they were labeled as safe, they were not. So you want to
you're
be
talking-
very sure you're getting it from a reputable source.
Yeah, what you're talking about is there were some counterfeit ISO certifications. Yeah, I understand that problem. It doesn't necessarily mean they're not safe, but it does mean the certification is bogus. We run into this. I used to run into this all the time in the electronics business with capacitors that were, from sources that weren't valid, and they would, bad things would happen in your electronics. So yeah, this is a problem with any kind of certification. Amazon tends to be better than a lot of the others, though. If it was
Amazon reported the problem.
Yes,
to the people who bought it.
Yeah. Yes, and that's why they're a good firm to deal with, or deal with one of the well-known and established photo dealers. And if you can get them from an astronomy dealer, so much the better. But their stock tends to be limited. I went and looked at some of those astro retailers, and everything was out of stock, which is kind of crazy since it's months and months away. But it's because they're small-time operations compared to Amazon or B&H or Adorama. Okay, the second method is projection. And this is what I would call indirect viewing. And the classic simple one there is the pinhole camera. You take 2 sheets of paper, you take a piece of aluminum foil, punch a tiny hole in it, tape the tin foil to the piece of paper, and you get an image of the sun. So it's very simple, it's very easy to use. However, it does have some limitations. So the pro is it's easy to use, simple to make. The con is you have a choice between either a small bright image or a larger fainter image, because it doesn't collect much light. And to make the image bigger, say 1 inch in diameter, would require 10 feet between the 2 pieces of paper. And you're not going to do that. Would sort of nullify all the advantages of it, and it would be very faint. But it does work, and if you space them 3 or 4 feet apart, you can actually see the partial phases progress. But it is really a very limited way of doing it, but it has the advantage that it's very safe and it's very easy to do. It's a good thing for young children. So suppose you want to increase the brightness. Well, instead of using a pinhole, you use a lens. It's not a safety, even though it concentrates the light, it's not a safety issue because you're not looking directly in line with the lens. And you can increase the size by using a magnifying lens. And the concept is basically this: the sunlight comes into the lens, it goes into a negative lens that projects it onto a screen. And you view the screen remotely. You don't put your eyeball in line with it. You view the screen by reflection. And this was developed by Charleston College, or the College of Charleston. And this is their solution for this. It shows 2 different versions with slightly different lenses. It's a 36-inch cardboard shipping container. One of the lenses is placed at the front. The projection lens goes in the middle on this piece of cardboard that's held in place with binder clips. It's very elegant. And a piece of paper down at the other end of the box. And that's actually the size of the disk of the sun you'd get. Notice these are 2 different versions, but they're basically the same. Notice the aluminum foil on the middle place where the projection lens is. That's because if you don't have the aluminum foil there and the focused light of the sun from the main lens hits that cardboard, it's going to catch on fire. But notice also that if you look at the box, the lower of the 2 boxes, you'll notice there's a bright spot on the projection lens. That's actually the light coming into the viewing instrument that's passing through that lens. And just with the slightest bit of dirt on that lens, you're going to reflect back a lot of light. It's not a problem. In fact, it helps you point the thing properly. And you get a nice big image of the sun. So that's nice. Of course, you have to figure out a way to mount it and hold it in place and then be able to move it to follow the sun. Because the sun moves 15 degrees an hour, and it's only, the field of view here is only about a little more than half a degree. So you're going to have to move this thing several times, every couple of minutes to keep the sun centered on it. So you need some way to mount it sturdily, but this will definitely work, and it's very safe, and it produces quite a nice image, actually. They have a website. If you just Google Charleston College Safe Solar Viewer, you'll find it. That's what SSV stands for. There's an outfit in Pennsylvania called Surplus Shed that sells lens sets for about $10 to make these. And if you get together a bunch of friends, you can buy 25 of those corrugated boxes from Uline, as well as other shipping sources, and have these nice corrugated boxes that are elongated. You could, of course, always make it yourself using some using some hardboard and a bit of wood and some screws. And there's another way to view it indirectly by projection, and that's called solar funnel. And this was developed actually and shown at the 2003 Great Lakes Planetarium Association conference, which I suspect Megan went. Well, I don't know if Megan was in Wayne State at the time in 2003. I don't think she was, but I'm sure Wayne State had representatives there. The basic idea is you take an oil funnel, you cut one end off, you cut the narrow end off of it so you can clamp an eyepiece in it with a hose clamp, and you put a sheet of projection film, which you can buy on Amazon quite cheaply, over the other end and hold it with a hose clamp. And then you point your telescope at it. And many people, the advantage of this, of course, just like with the Safe Solar Viewer from the College of Charleston, many people can look at this at the same time. You're not in any danger because you're not looking directly through. You don't need a filter in this case because the sun, and you don't want a filter because the sun's light is dimmed because it's spread out over a disk of 4 inches. So it's completely safe to use. Many people can view at the same time. And it works, of course, in conjunction with an unfiltered telescope. And so this is basically the concept. The light comes in, it becomes very concentrated at the focal point of the main lens, but then the projection lens, which happens to be an old eyepiece, the projection lens magnifies it and puts it out on the screen. And the whole thing is enclosed by the funnel. And so that's a nice, simple solution. It assumes, of course, you have a decent telescope that you can hook it to. And again, it's unfiltered in this case. And of course, the reason it's safe is because the image of the sun is expanded, so the intensity is decreased. The same amount of radiation is painted over a large image, so it becomes dimmer, and the projection screen is semi-opaque. And this shows you basically what's involved in making one. And there's I'll give you the website from NASA from the 2017 eclipse for making these. The one caveat is the eyepiece you use for projection should have no plastic parts. Why? Because the eyepiece is right in the main path of the sun's light, which is very intense. And so you don't want any plastic there. You want glass and metal. But aside from that, it's very simple to make. The instructions are on the web, and they're at this website, Eclipse 2017, nasa.gov, make sun filter. So that's another option for projection. And another plus of the College of Charleston Safe Solar Viewer and the Sun Funnel is that after the eclipse is over, you can use them to look at sunspots because we're coming up on the solar maximum. The pinhole camera won't, except in extreme cases of huge sunspots. The pinhole camera won't let you view sunspots. But these other two solutions will allow you to look at sunspots safely, as would a telescope with the front filter. But wait, there's one factor we haven't talked about. How do we find the sun weather instruments? This may seem kind of paradoxical because the sun is so bright. But remember, the telescope or the Safe Solar Viewer, the telescope, whether it's got a filter in front or whether it's got the sun funnel at the back, or the Safe Solar Viewer, those have field of views of only about 1 degree, which means we have to point at the sun within 1 degree or so. And that while that may not sound like much, 1 degree is not very much. The full moon and the sun are only 1/2 degree. So it's kind of hard to point it at the sun, particularly since the sun is so bright to your eyes. It's not like you can put your eye up there and sight up the telescope and look at the sun, because the sun is going to be dazzling, not to mention dangerous. Well, with binoculars, it's not a problem because binoculars have like a 7-degree field of view. So if you have binoculars with filters, then it's not really a problem because the field of view is so large, you can find the sun. The other two have narrower fields of view. So they have to be pointed carefully. So how do we do this? Well, Orson Welles knew the answer. I don't know if that 1930s laugh came through okay on your end, but I remember listening to it when I was a boy in the basement building plastic models on the radio. Yes, the shadow knows. With the same solar viewer, all you've got to do is line up to the box so that the back of the box is completely in the shadow of the front. Plus, you can see the reflection of the sun in the on the aluminum foil and center it that way. With a telescope, if you move the telescope so the shadow of the telescope is smallest, then you're going to be very nearly pointed at the sun. Or you can use a narrow tube as a finder. And they actually make these, of course. This is an example of one. It's basically a sort of like a pinhole camera. It's got a hole and a screen at the back, and it projects this tiny amount of light. A very small amount of light comes through here, and it is put onto this little projection screen, and you simply center the sun. You can buy that, or you can do like I did and spend about $2 on PVC pipe fittings and make one yourself. This is one I made because I have a telescope with a standard finder base, which is the silver thing, and two pressure test caps, and a piece of PVC pipe, which I had in the basement, will make the equivalent. It's got a semi-translucent piece of plastic stuck on the end there. So you can make one of these yourself. You can align it with your telescope in advance, and then you don't have to worry about it during the eclipse. Nothing would be worse during an eclipse than to not be able to find the sun. It'd be kind of embarrassing, but I've seen it happen. So in closing, we've given you a variety of safe ways to view the non-total phases of the eclipse. The total phase, if you're in the path of totality, is a no-brainer. You'll believe me, when you see this, if you're in the path of totality, when you see the sky go dark and you see stars pop out, you'll know it's safe to look without filters. But at all other times, you need filters. But none of this is a substitute for common sense and diligence. You use your brains. And equipment should never be left unsupervised. And of course, the same goes for children. Children shouldn't be left unsupervised either, and certainly not when there's equipment around. Some references. If you're interested in traveling someplace to go to see the total eclipse phase, if you go to the eclipsecompany.com, one word, theeclipsecompany.com, they're partnered with the Planetary Society, and they have a really nice website, which I showed you that one band picture, which you can zoom in on an area that you might want to travel to. It'll show you where there are eclipse events that you can go to. In the Detroit area, very conveniently, right near the center line is Cleveland, Ohio. And if you go to the Great Lakes Science Center, whose website is greatscience.com, you'll look at you can find their Total Eclipse Fest 2024 website. If you're interested in eclipse timing for either this eclipse or other eclipses, like the lunar eclipse that's coming up soon, you go to timeanddate.com, timeanddate.com, and they have a tab for eclipses. And with that, I'd just like to show you a couple things, dog and pony show. I showed you these before. The eclipse glasses, again, make sure that they have the proper certification. And again, the best way to do that for most people, buying that 4-pack for $20 is probably your best bet. They're from a very reliable source, Celestron. If you need, when I went to the last eclipse down in Missouri, I actually made a set of filters for my binoculars, but you can buy them. I waited too long, of course, so I had to make my own. And basically they fit over the front. And again, it's the same kind of material. It passes less than 1/100th of 1% of the light. And so with these in place, it was perfectly safe to look at the partial phases of the eclipse in Missouri. And of course, during totality, I took them off and put it back on when totality was over. And I think that's it. So we'll see if there's any questions. We have plenty of time, close to 40 minutes for questions if need be. So over to you, Jennifer or Ethan.
Yeah, thank you for the wonderful lecture, Mark. We have one question in the chat so far. This is from Jerome at Rock, who asks, have you ever had the eclipsed sun shine into a kitchen colander? It makes a nice image of a lot of crescents on the ground. Is this safe?
Yeah, sure. Just as long as you don't stand behind the colander. If it's projecting onto the ground, it's great.
Yeah, it reminds me a bit of the pinhole projector that you had mentioned, but just with many, many pinholes.
Yep, yeah, and you'll find on the web, I forget who did it, but at various eclipses, people have photographed what you would see if you were underneath a tree that had lots of leaves on it, and there were a few gaps between the leaves, and you would get this random pattern of crescents on the ground caused by the gaps in between the coverage of different leaves where they overlapped. So yeah, the colander trick would be nice. It would be cute. Again, they're not going to be very big. The problem with the colander, of course, is that the holes would tend to be a little on the large side. But still, yeah, you will see a multitude of crescents if you do that. But it's perfectly safe because you're not staring through the colander, you're looking at its projection. So it's one of the two safe methods. If you're looking directly towards the sun, you have to have a filter in front of the first lens, whether that first lens is your eye or whether that first lens is your binocular objective or your telescope objective.
You're also getting a few people saying, well done. And Shirley Shane says, thank you very much. This was very interesting and informative. So I wanted to pass that along to you, Mark.
Very good.
We also have a question from Ed Pink, who says, I plan on driving to Ohio. I don't know when the next opportunity will be in this area. How many total eclipses have you seen? They've read about eclipse chasers.
Well, I've been an eclipse. There were two phases to my eclipse chasing. One was before I started working, and the other one was after. The first one was in 1969, I guess, down in the Carolinas. In fact, the path of the eclipse was almost the same as this one, except it was shifted east. So I saw that one. Then I saw one in 1970 in the Gaspé Peninsula of Canada. Then in 1973, off the coast of Dakar, near the equatorial bulge of Africa. Then I got busy with my career and life, and then in 2006, went to Libya, of all places, to see a total eclipse, which was just wonderful, just beautiful weather, perfect. Then in 2008 or 9, went to China. And then in 2017, the one down in Missouri. So some eclipse chasers go after every single one. I'm sort of in the middle of the pack, I guess. The next one visible from the US is 2044. So depending on how old you are, this may be your chance.
Dr. Christensen did a show for us about a year ago, about his chasing eclipses all over the world. As he says, he's not as enthused as some people, but you can find it. This is our YouTube channel for the astronomy programs. And it's near the top, 50 years and 6 total solar eclipses.
That is it for the questions so far. But if anyone else has any, please do pop those in the chat.
Yeah, all we can do is all light a candle for good weather.
Indeed.
That's always the thing that matters.
a lot of libraries, including the Detroit Public Library, will have eclipse glasses available. We will have some to give away before the day of the event for people who are traveling. There are several NASA programs and other programs for libraries that have provided us with eclipse glasses, and DPL has bought more. So, but we will definitely have programs here at my branch, which is the Knapp branch. It's on Conant near Davison in Detroit. And I know the main branch on Woodward and near Warren will be having events. And we hope to work with people at the planetarium on that. And we will have several programs preparing people. And this, I will be encouraging people to play this for groups to give some idea of how to do this safely.
Yeah. And if you do plan on traveling to see the eclipse, whether it's to Ohio, Indiana, Montreal, I mean, the southern half of the island of Montreal will see it, weather permitting, or down to Texas like we're doing, or Arkansas. If you do plan on traveling, please give yourself plenty of time. If you're driving especially, give yourself plenty of time. And if you are going to attend an event, get your reservations in as soon as you can. Some of these places are filling up, and some of them are quite reasonably priced, and some of them are absolutely outrageous.
And be prepared for traffic jams.
Oh yeah, well, in fact, when we went to Missouri, we went down the day before to Columbia. We observed it from Columbia in 2017, and we went down the day before and stopped in at Westminster College in Fulton, Missouri, which happens to be where the Churchill Archive for the United States is, as well as a reconstruct. I think it's in the lecture that you talked about, Jennifer. There's actually a reconstruction of a Christopher Wren church there.
Yes, I remember that.
Yeah, and so we went down the day before, and we observed the eclipse and had a nice dinner in Columbia, which is a college town, and then drove back the next day, and we had no problems. But some of our cohorts left right after the eclipse, and they never made it out of Missouri that day. And there was a big event down in Southern Illinois University, which is right near the center line for this one as well. And people spent 8 hours getting out of the parking lot. So, plan appropriately, give yourself time. Don't think you're going to jump in the car and drive down under normal traffic conditions, because it will get crazy.
There are also a lot of car accidents right before the eclipse. I made the mistake in 2017 of trying to get out of class at noon and then drive up for this 2:30 eclipse in North Georgia. And people were just gawking at the sky, and I ended up getting pancaked. So just be very careful if you can about this timing.
Yeah. And a lot of places in Missouri, they actually were warning people, don't pull off to the side of the road, because the police are going to be out there giving tickets like crazy for that, because of the hazard it creates. I don't expect that would be a problem on a small country road, or finding a church parking lot or something, but you're better off planning in advance where you're going, and making sure you make proper arrangements and give yourself time.
Jennifer Lewis adds, when we drove to South Carolina to see the eclipse there, I presume the 2017, we drove around trying to avoid the clouds, and that was nerve-wracking. We ended up in a parking lot in the middle of nowhere and saw the eclipse well.
Yeah, but it is nerve-wracking if you have to do that.
Do we have any more questions?
Yeah, if you make it, by the way, I mean, when we go to eclipses, we try to make, Arlene and I, we always try to arrange it so there's other things to do in case we're clouded out.
Yes, well, we try to have these programs on the fourth Tuesday of the month. Next month, our Adrian Bradley, who's done several programs for us, is going to talk about how to photograph an eclipse. So that should be helpful too, and he will stress safety as well. Yeah. I remember in 2017 seeing a lot of people pointing their cell phone cameras at the sun, and I did not find out what results they got and if they damaged their cameras.
Well, that was why one of the filters I showed actually is designed specifically
Yes.
to fit over a cell phone. And again, for partial phases, you absolutely have to have it. The problem with, of course, I'm not totally up on the latest cell phone cameras. I know some of them have like built-in wide angle and telephoto and regular lenses. They have like 3 or 4 in there. But most cell phone cameras, at least the ones I've seen, the images are all going to be awfully small. So you might be disappointed. But some cell phone cameras, I guess, have telephoto lenses built in them now.
Mhm.
When I go to eclipses, what I take is this. It's basically a 500 millimeter telephoto lens. It's a small telescope, and it's got a flip mirror, so I could put a camera on the back, and then I can view it during the partial phases or during totality. I could view it with the eyepiece and then flip the mirror up and then photograph it. So I don't have to be dancing around with 2 different telescopes. And that's how I do it. And I just use a regular DSLR. You don't need any special astronomy cameras for this stuff.
No, Adrian is very good at telling how to use fairly common equipment, not the real special equipment, to take good photographs of an eclipse, or he did one program on how to photograph the moon, which in a lot of photographs looks like a blob.
Yeah. Well, that is one place where cell phones can actually do something, because with the moon, they actually make brackets that will allow cradles that will hold the cell phone so it looks down into the eyepiece of the telescope and does what's called afocal photography. And when we have public events at our local astronomy club, we actually let the members of the public put their cell phones into the cradle and let them take a picture for them to take home with of the moon. So that is one way you can use cell phones, but it's in conjunction with a telescope. And of course,
Yes.
with the sun, it would need to be filtered just like it would need to be with your eyeball.
Yes, well, Dr. Christensen did give several companies that can that do sell filters. It's getting late, but it's not totally late. I think the specialty sources might be having problem because of lack of volume.
Yeah.
But you should still be able to get some of these filters.
Yeah, like I said, I checked Amazon, and they had the Celestron and several of the other reliable makers still had stock. And it's because of the purchasing power of an operation like Amazon.
Yes.
Or PH Photo Video or Adorama. I don't know about Abe's of Maine, but there are several large online camera dealers that will carry these things too.
I'm not an expert, but I do try to keep people informed. If you'd like to be notified of events, these events, you can email me at jdye@detroitpubliclibrary.org. Thank you, Dr. Christensen. It was very enjoyable and very informative. And thank you for your help, Ethan.
Of course.
Okay. Okay, everyone. And just remember, I used to test missiles out at various government ranges. And at the end of every morning safety briefing, the safety officer always said, and remember, the most dangerous thing you're going to do today is get in your car and drive.
Yes.
So remember that when you're traveling to and from the eclipse.
Definitely. Definitely. Well, thank you. And I hope to see everyone later. And you can see Dr. Christensen in 2 programs, including the Eclipse Chasing and the James Webb Space Telescope Science and Technology.
Thank you.
Thank you.
Jennifer.
Talk
Thank you,
with you later.
Ciao.
Bye, everyone.
Goodbye.